Hi and welcome to the video on log graphs. We saw the exponential graphs video just before. Log graphs are somewhat similar, in fact they're the inverse of exponential graphs. So they have some similarities, but a little bit different, I guess, as well. So first of all, I'm going to show you the standard form of a log graph, which is, as I like to put it, like this. So it looks exactly the same as all of the other graphs that we've looked at. It's just now we've got a log attached to it, and again I'm going to use e, log to the base e. You could use log to the base of any positive number, but I'm going to use log to the base e. Now the standard log graph looks like this. It sort of goes from the negative, the asymptote, which is at x equals 0, and it goes up and it gets further, it gets bigger and bigger and bigger and bigger each time. But the rate at which it's getting bigger is actually getting smaller. So it's an increasing function, but the gradient is decreasing, which we'll look at that in calculus in probably chapter 6, I think. It has an x asymptote as opposed to the exponential graphs, which have a y asymptote. The x asymptote is x equals 0. The domain is everything greater than the asymptote, in this case x equals 0. And the range is all real numbers, okay, which is very similar to the exponential graphs. It's just these two things are swapped, okay, because that's what inverse does, but we'll look at that a little bit later. The same dilations, translations, and reflections apply to all of these graphs, and so I guess I won't go through all of those again as I went through those in the exponential ones. I'll just show you some examples for this. Okay, so here are two examples. Let's look at the first one first because that's logical. This one has been dilated by a factor of 2 from the x-axis. Okay, so everything has been stretched away from the x-axis, and it's also been translated 1 unit up. Now for this, again, like the exponential graph, sometimes you can't tell the difference. And for us, a dilation from the x-axis, we can't really tell the difference unless we see the other one on the same axis as well. And again, with a translated 1 unit up, it doesn't really look any different from our original graph over here. The only difference is that it has a different x-intercept this time. Okay, so we can put in the x-intercept, rearrange it to find the y-intercept. Okay, for this one here, I don't know how to draw that, but I do know how to draw one that's rearranged. So I'm going to make it a log e of x minus 2 plus 1. That looks much better for me. So I can tell you it's been reflected in the x-axis, it's been translated 2 units right and 1 unit up. So therefore the 2 units right is most helpful because that's our asymptote, and we can make that x asymptote as 2. It's been reflected in the x-axis, which means instead of going up, it now comes down. And it's been moved 1 up, but again that doesn't really make sense to me, so all it means is that the x-intercept will be a little bit different. Okay, but we can find that out using algebra anyway. Okay, the third and fourth example, the final example, I've got this one here. I don't know how to draw that one, but I do know how to draw this one here. So I take the negative out as a common factor, which means this one's a reflection in the y-axis because the negative is inside the bracket. It's also been translated 2 units right and 1 unit down. So I put my asymptote in because I know that's x equals 2. It's been reflected in the y-axis, which means instead of going this way, it now goes this way. And it's been moved, we've already moved it 2 units right, and it's been moved 1 down. Again, it just changes the y-intercept. I can find both of these points using algebra, subbing in x equals 0 and subbing in y equals 0, and finding those 2 points. And that's what the graph will now look like. This final one, this one's probably like a tricky one. A harder question. It looks really ugly, but it's not too bad in the end. Y equals negative log e of the square root of negative x. Now, just using my indice laws of knowledge, I can find that that's negative x to the power of a half. I can drag that half down the front. So now I can tell you that it's dilated by a factor of a half from the x-axis, reflected in the y-axis, and also reflected in the x-axis. And the drama room's just going a bit crazy, if you can hear that background noise. Anyway, we'll press on. So it's still got the x asymptote of 0, but it's been reflected in the y and in the x. So instead of looking like this, it's been reflected in the y, so it looks like that, and then finally reflected in the x, which it looks like that. And we can find out the x-intercept by subbing x equals 0 into that. Hopefully that has made a little bit of sense. Remembering that we can apply a whole bunch of other things to these as well, like we can apply the absolute to all of these graphs, and we'll have a look at that as some of those trickier type questions later on. If you've got any questions, please ask me. Otherwise, enjoy chapter 2.3 and 2.4. Thanks.